What's up, guys? This is our enthalpy of vaporization lab, where we're going to look at three different liquids and look at how much energy is absorbed as they evaporate, as they turn from a liquid to a vapor or a gas. So we've got water, acetone, and ethanol, and you can take a look at them. They're all clear liquids. They all look kind of the same. They're all the same state. They're all at room temperature right now. And what we're going to be doing is letting them evaporate, letting them turn from a liquid to a gas. And we're going to see how the temperature changes as they turn from a liquid to a gas. And we'll be looking at which one evaporates the fastest and which one absorbs the most energy as it is turning to a vapor. All right, so the way we're going to do this, we've got a thermometer and we've got a piece of filter paper. And I'm going to roll that piece of filter paper around the thermometer. So it looks kind of like this. So we've just got a piece of paper wrapped around a thermometer, and the paper is just so that it can absorb some of the liquid and hold it against the thermometer. All right, so now I'm going to dip my thermometer into the liquid. We'll start with the water, and right now we're just finding the initial temperature of the water. And so the initial temperature of the water as it's a liquid looks like 19.8 degrees Celsius, 19.7 degrees Celsius. And so we'll pull that out, and you're going to record the temperature every 30 seconds. You need to start a stopwatch when I pull this out. Your temperature at time 0 is going to be 19.7, and then every 30 seconds after this, you're going to record another temperature. All right, so we'll pull that out, set it up like this so you can see it. And every 30 seconds you need to record the temperature. What's happening right now is that this piece of paper is wet and it is slowly evaporating. It's slowly turning into a vapor. And as it turns into a vapor, it needs to absorb energy. In order to change it from a liquid to a gas, you have to break those intermolecular attractions, that force that's holding it together as a liquid. And so to break that attraction, to break those intermolecular bonds, you need to absorb energy from the surroundings. And as it absorbs energy from the surroundings, this little piece of paper and this thermometer get colder. So you can see the temperature is dropping a little bit as it turns from a liquid to a vapor. And so every 30 seconds, you need to record the temperature. At the end of this, you're going to be making a graph. And so on your graph, you're going to have time on your x-axis. And you'll record a piece of data every 30 seconds. So along your x-axis will be time. And then on your y-axis, you'll have temperature. And so you'll see how the temperature changes over time. And we're going to do that for each one of these liquids. So right now we're doing it for the water. And then after this, we'll do it for the acetone and ethanol. And that way you're going to be able to compare how quickly the liquids evaporated and how much lower temperature each one reached. So what we're looking at here is evaporative cooling. You guys have all experienced evaporative cooling when you sweat or when you get out of the shower or get out of a pool. As your body is wet and then that water, that liquid on your body starts to evaporate and turn to a vapor, your body starts to feel colder. Right? That's why we sweat, to help cool ourselves down. And so the way sweating works is that you have liquid water on your skin, and then as that liquid turns to vapor, it absorbs energy from the surroundings. And the surroundings could be your body, and as it absorbs that energy, then your body's going to feel cooler. It's going to remain cooler because some of that energy is taken away as the water turns from a liquid to a vapor. And we're seeing the same thing on the thermometer right now. Right? Like imagine this was your skin and it was wet, and then as this is turning to a vapor, what's left behind, this piece of paper and the thermometer, are getting colder at a lower temperature, and just the same way that your body feels colder as sweat or water would evaporate off your skin. All right, so continue every 30 seconds. You need to record the temperature, and then that's going to give you the data that you need to make your graph, with time on the x-axis and temperature on the y-axis. It's continuing to get colder and colder as the water continues to evaporate. All right, guys, so you're continuing to record the temperature every 30 seconds. You can see right now we're at 12.6 degrees Celsius, 12.5 degrees Celsius. The temperature's come down significantly since we first started. And we're going to compare this to the other liquids. Right? The reason the temperature is dropping is because energy is being absorbed from the surroundings in order for this phase change to take place. You need to take energy out of the liquid you need to put energy into the liquid in order to change it to a vapor. And that energy that's going in to turn it from a liquid to a vapor is coming from the surroundings. And so that's why the surroundings, like this piece of paper and the thermometer, are getting colder. So we'll do this for about 1 more minute, and then we'll stop and we'll switch to the other liquids, which are acetone and ethanol. All right, so that's probably good for the water. You can stop collecting data, and then we're going to continue with the other two liquids, and we'll be able to compare how easily they evaporated, how quickly they evaporated, and how low the temperature gets.